Michael Tesler, or as he is known here, MH, grew up in the Tidewater region of Virginia, where he graduated as valedictorian of his high school class in 2007. He attended the University of Virginia, where he explored his diverse interests in philosophy, history, economics, and astrophysics before graduating a year ahead of schedule with distinction and a bachelor's degree in mathematics. Through his undergraduate coursework in philosophy, MH grew interested in questions about the human mind. After graduating from Virginia, he went to the National Institutes of Health in Bethesda, Maryland, where he worked as a post-baccalaureate research fellow for 2 years, investigating brain connectivity patterns in typically developing adults and young adults on the autism spectrum. In 2013, MH joined the psychology PhD program here at Stanford to work with Professor Noah Goodman in the Computation and Cognition Lab. In his doctoral research, MH developed computational models that try to predict and explain what people mean when they say things that are vague, indirect, or ambiguous. In other words, when people don't say what they mean. His dissertation was on language used to express generalizations, or general statements such as ducks fly, Stanford students excel in their work. His research was supported by a National Science Foundation Graduate Student Fellowship and has been presented internationally at numerous conferences and workshops. Outside of his academic work, MH likes to travel and explore new places and cultures. He's maintained a blog about his travel since he was 15 years old. In the fall, MH will be joining the Department of Brain and Cognitive Sciences at MIT as a postdoctoral research scientist, continuing to conduct basic research at the intersection of psychology, linguistics, and computer science. I'd like to invite MH to the stage.
Thank you, Ian, for that lovely introduction, and welcome everybody. Congratulations to our graduates and to our friends and family here with us today, and happy Father's Day. I'm here to tell you what it's like to be a graduate student in psychology at Stanford. After you tell someone you're getting a PhD, the most frequent question you'll be asked is, what are you going to do after you get your degree? It seems like an innocuous question, but it's kind of strange. It's sort of like discovering somebody's in the military and then asking, what are you going to do when you get out? For most of the time in graduate school, the end is not in sight, and the question of what to do after often not even considered. This strikes many as odd, and it is. What do you do when you're done with medical school? Well, be a doctor. What do you want to do after you're done with law school? Probably be a lawyer. What do you want to do after you're done working to get a PhD? The answer is no longer work to get a PhD. Being a PhD student is only superficially like being in school. Getting a PhD is actually more like having a normal job while you also attend night classes. We get paid, which is why it's like a job, and we have to take some classes. But the real reason why we're here is to conduct original research. Conducting original research involves meetings, planning, training research assistants, collecting data, analyzing data, having more meetings, analyzing data in new ways, putting together presentations, writing research papers, and the list goes on. Sometimes we have to help professors teach their classes, sometimes we teach classes of our own. In fact, there are so many different things you have to do as a PhD student that the only thing you get used to doing is doing things for the very first time. In that way, getting a PhD is both one of the most interesting and also one of the most challenging ways you could spend 5 or more years of your life. But it's still school. You are a PhD student, after all. Is that any different from being any other kind of student? What I can say is, the food is different. When you're in grade school, elementary, middle, or high school, you have no options of what to eat. Whatever is being served in the lunch line today is what's for lunch. And the curriculum is the same. 4th graders don't get to choose their classes. At a certain point, you might get to decide if you want to take band or art, kind of like you have the choice of juice or milk at the end of the lunch line. But that's it. Okay, then you go to college and suddenly the food is amazing. Not only is it amazing, but you have dozens of options and you can have as much as you want whenever you want. You want a waffle with guacamole, roasted peanuts, and kale? Go for it. Classes are the same. You can fill your schedule, or as Stanford undergraduates like to do, overfill your schedule with whatever you like. Astronomy, history, psychology, literature, mathematics, dance. It's incredibly intellectually interesting, and topics are designed in these beautiful, manageable portions we call classes. Now, in graduate school, nobody makes your food for you. You have to buy the ingredients and make the food yourself. And probably the first time you make it, it's not going to taste great or look as beautiful as it did when somebody else made it. The PhD curriculum is the same. It's self-made. You learn whatever it is you want to learn in order to do whatever it is you need to do. And what do you need to do? Well, whatever you want to do. With the one constraint that it must be worthy of a PhD, which is determined somehow by the people behind me. Now, as a PhD student, you sometimes need to make something for which the ingredients don't yet exist. You see, you can't just go to the store and buy some flour because you need a very particular kind of flour that can't really be found anywhere else in the world except maybe with a strange researcher in Budapest, but the shipping costs would be insane. You have to grow your own wheat. By which I mean, some of us arduously design and build toys that babies play with in order to reveal something about how babies think. Others of us build close relationships with the Department of Motor Vehicles in Oakland, so you can go and interview people about how they feel about the police. Others of us, this is all real. Others of us impersonate owning industrial washing machines in order to access the data on the machines to better measure the impact of social messaging on people's water use. And in order to more accurately describe the basic functions of cognition, some of us develop new computer programming languages. Now, each of these ingredients is a side project. It's actually not the main research question we're after, but it's necessary if you want to get to where you want to go. So the next time you encounter a PhD student, rather than what are you going to do after, ask them about the ingredients of their research. Or just ask them, how do you actually do your research? I guarantee you the answer will be much more interesting. Now, I came to psychology rather late in my academic life, after undergraduate. And I'd like to share some of what I've noticed after coming here. Psychology is a rather young science. We don't have an Isaac Newton or a Niels Bohr who has dramatically reshaped and irrevocably reimagined the way we think about the topic, but there have been a number of smaller revolutions. This is why psychology is one of the most exciting branches of the sciences. The major discoveries, it seems to me, are still before us. Psychology is not, as I had once thought, and what is known somewhat pejoratively, as a soft science. Psychology is a hugely empirical science, which draws heavily on the method of Francis Bacon and of Isaac Newton. But the method, the scientific method, is not foolproof. It is not the method of mathematics, for instance, which offers complete and undeniable proofs of certain universal truths. Experimental methods, like those employed in psychology, rely upon observation, manipulation, and the discipline of statistics in order to draw somewhat generalizable conclusions from a purely limited number of observations made in a study. But to draw those conclusions, certain assumptions and caveats must be made. The current era of empirical sciences, broadly, in the past 5 or so years, is grappling with the limitations of this method. and trying to resolve what practices scientists should employ in order to most effectively use the scientific method. This grappling, what is called in the media as a reproducibility crisis, covers all empirical disciplines: medicine, epidemiology, political science, and many others, including psychology. The issues about how best to do science are deep and technical and require an understanding of experiments, statistics, and why it is we draw generalizable conclusions from a limited number of observations. Psychology is actually the field most seriously confronting these issues.